12.2 is about chords and arcs. In this problem, now there's a bunch of theorems and things that I didn't want to get into, and it talks about the likelihood of what's equal to what and everything else, so I didn't really want to get into those. Let's just go through our method of practicing, and we'll kind of come to the conclusions here. When you're looking at this drawing here, if you know that PQ is 12.5, then you also know that QR is 12.5. Let me use another color here, make it a little easier. You also know that this is 12.5 as well. So PR then is going to equal 12.5 plus 12.5, which is a length of 25. Now, if PR is 25, notice how, see how this is 9 and this is 9? PR and SR are equidistant from our center. So since that is the case, PR is equal to SR. And that means SR is going to equal 25 as well. If we're looking here, we're trying to find R in problem A. That looks to be the hypotenuse of the right angle right there. Okay, and we're talking about a chord and a radii, and as you come down, it forms a 90-degree angle. So again, we have a right triangle. If this whole diameter is 14, well, that means my radius has to be 7. It's half of my diameter. So R being my hypotenuse, R squared equals 3 squared plus 7 squared. So that gives me R squared equals 58. When you just punch it in your calculator, take the square root of both sides, I get R equal to approximately 7.6. Now in B always seems to be the struggle. We've got 11 over here, we've got Y over here. I got this 15 sitting out here. Notice that 15 right here is a radius. Radius are all around the circle, so this is also a radius right there. Why? Because it goes from the center to the circle. So that's going to be 15 as well. And this is where we struggle. Make sure that you draw in that 15. Again, that's across from the right angle, so 15 squared equals Y squared plus 11 squared. Do this out at 225 equals Y squared plus 121. Subtract 121. I get Y squared equals 104. Now take the square root of both sides and end up with Y is about 10.2.